Long before telescopes scanned the skies, before calculus cracked the code of motion, before the world knew Copernicus or Galileo, there was a young thinker in ancient India who dared to ask, what if the Earth spins? What if numbers could unlock the secrets of the stars? His name was Aryabhatta. Born in 476 CE, in a land where myth ruled the heavens, he chose reason. At just 23, he wrote a book that would echo through centuries, a poetic masterpiece of mathematics and astronomy that challenged everything the world thought it knew. He calculated pi, mapped eclipses, and hinted at a heliocentric universe, nearly 1,000 years before Europe caught on. He didn't just count stars. He redefined how we count, how we measure, how we think. This is the story of Aryabhatta, the boy who looked up, the scholar who saw beyond, and the legacy that still guides our journey to the stars. The inspirational journey of Aryabhatta, from curious child to eternal legacy. In the annals of history, few names shine as brightly as Aryabhatta, the ancient Indian mathematician and astronomer whose insights transformed the way we understand numbers, the cosmos, and the very nature of scientific inquiry. Born in a time when myth often overshadowed reason, Aryabhatta dared to look beyond tradition and seek truth through observation, logic, and mathematics. His story is not just one of genius, it's one of courage, curiosity, and timeless impact. Childhood and early life. Aryabhatta was born in 476 CE, and while the exact location of his birth remains debated, most scholars associate him with Kusumapura, a region believed to be modern-day Patna in Bihar, India. Some traditions suggest he may have hailed from Ashmaka, possibly located in present-day Maharashtra or Kerala. Regardless of his birthplace, Aryabhatta's intellectual roots are deeply tied to the rich scholarly traditions of ancient India. From a young age, Aryabhatta exhibited a profound curiosity about the natural world. Unlike many of his contemporaries who accepted mythological explanations for celestial phenomena, Aryabhatta questioned the stars, the movement of planets, and the nature of numbers. This inquisitive spirit led him to pursue advanced studies, likely at the famed Nalanda University, one of the world's earliest centers of higher learning. Nalanda was known for its astronomical observatories and rigorous mathematical training, an ideal environment for a mind like Aryabhatta's. The Aryabhatta, a masterpiece of ancient science. At the age of just 23, Aryabhatta composed his magnum opus, the Aryabhatiya. Written in Sanskrit verse, this compact yet profound treatise consists of 108 verses divided into 4 chapters. 1. Gitigapada discusses large numbers and the measurement of time. 2. Ganitapada covers arithmetic, algebra, and geometry. 3. Kalakriyapada deals with planetary motion and time calculations. 4. Golapada explores the geometry of celestial spheres and astronomical models. What makes Aryabhatta remarkable is its blend of poetic elegance and scientific precision. Aryabhatta used a unique substitution code to represent numbers with syllables, making the text both mnemonic and mathematically rich. His work was revolutionary not just for its content, but for its method. He introduced a systematic, logical approach to understanding the universe. Mathematical brilliance. Aryabhatta's contributions to mathematics were centuries ahead of their time. Among his most notable achievements, value of pi. Aryabhatta calculated as approximately 3.1416, remarkably close to its true value. He stated that the circumference of a circle divided by its diameter is approximately 62,832 20,000ths, which equals 3.1416. Place value system and zero. While he didn't use a symbol for zero, Aryabhatta's work clearly demonstrates an understanding of the place value system, which is foundational to modern arithmetic. Algebra and geometry. He developed formulas for calculating the area of triangles and circles and solved quadratic equations. His geometric insights laid the groundwork for later Indian mathematicians like Bhaskara I and Brahmagupta. Trigonometry. Aryabhatta introduced sine tables and defined trigonometric functions in a way that would later influence Islamic and European mathematics. His mathematical innovations were not just theoretical, they had practical applications in astronomy, architecture, and timekeeping. Revolutionary astronomy. Aryabhatta's astronomical theories were equally groundbreaking. At a time when many believed the Earth was flat and stationary, Aryabhatta proposed that the Earth rotates on its axis, explaining the apparent movement of stars across the sky. The planets orbit the Sun, a heliocentric idea that predated Copernicus by nearly 1,000 years. Eclipses are caused by shadows. He correctly explained solar and lunar eclipses as the result of the Earth and Moon casting shadows, rejecting the prevailing mythological belief that eclipses were caused by demons like Rahu and Ketu. Aryabhatta also calculated the length of the sidereal year, the time it takes Earth to orbit the Sun relative to fixed stars, as 365 days, 6 hours, 12 minutes, and 30 seconds, a figure astonishingly close to modern measurements. His astronomical models were based on observation and mathematical reasoning, not mythology. This shift from superstition to science marked a turning point in Indian intellectual history. Classical building, career, and influence. Aryabhatta's reputation as a scholar and teacher grew rapidly. He is believed to have served as the head of Nalanda University, where he mentored students and conducted astronomical observations. Some sources suggest he established an observatory at the Sun Temple in Telangana near Patna, which became a hub for astronomical research. His influence extended far beyond his lifetime. Indian scholars like Bhaskara I, Brahmagupta, and Varahamihira built upon Aryabhatta's work, refining and expanding his theories. His texts were translated into Arabic during the Islamic Golden Age, where they influenced astronomers and mathematicians in Baghdad and beyond. Through these translations, Aryabhatta's ideas eventually reached Europe, contributing to the Renaissance and the scientific revolution. Legacy that transcends time. Aryabhatta's legacy is not confined to dusty manuscripts or ancient observatories. His name continues to inspire generations. In 1975, India launched its first satellite and named it Aryabhatta, honoring his contributions to science and mathematics. His work is studied in schools and universities across the world, and his methods are still relevant in fields like astronomy, engineering, and computer science. Statues, institutions, and awards bear his name, celebrating his role as a pioneer of rational thought and scientific inquiry. More than a mathematician or astronomer, Aryabhatta represents the spirit of intellectual courage, the willingness to question, to explore, and to seek truth even when it defies convention. Why Aryabhatta's story inspires us today? Aryabhatta's journey from a curious child in ancient India to a global icon of science is a powerful reminder of what human intellect can achieve. He lived in a time when myth and superstition dominated explanations of natural phenomena. Yet he chose a different path, one guided by observation, logic, and mathematics. His story teaches us that curiosity is the seed of greatness. Aryabhatta's questions about the stars led to answers that changed the world. Knowledge transcends boundaries. His work traveled across cultures and centuries, proving that truth is universal. Legacy is built on courage. Aryabhatta challenged prevailing beliefs and laid the foundation for modern science. In a world still grappling with misinformation and pseudoscience, Aryabhatta's life reminds us of the power of reason, the beauty of numbers, and the infinite possibilities of the human mind. Centuries have passed since Aryabhatta gazed at the stars and scribbled numbers that would shape the future. Empires have risen and fallen. Technologies have evolved, and yet his legacy endures, etched in satellites, textbooks, and the minds of dreamers who still ask why and how. He didn't seek fame. He sought truth, and in doing so, he became timeless. Aryabhatta reminds us that knowledge is not bound by era or geography. It is a flame, lit by curiosity, fueled by courage, and passed from one generation to the next. So the next time you look up at the night sky, remember, one man, over 1,500 years ago, saw what others couldn't and dared to write it down. This is not just history. This is legacy. This is Aryabhatta.